If you download the app on your phone, as of right now, it's still free to use. You just have to follow these instructions, place your phone in a stable stand, film your lift, and you get really accurate mean velocity measurements. If you want more advanced measurements, like peak velocity and stuff like that, really accurate advanced measurements, it's probably worth investing in some technology like a linear position transducer or whatever. But just as an entry point, I think these apps are an excellent option.
Hi, Alex. It's my pleasure to have you on Evidence Strong Show. If you could briefly introduce yourself.
Yes, of course. My name is Renner. I'm a powerlifter and employee and student at the University of Vienna. I'm working in the field of velocity-based training, and that's also why I'm here today.
Awesome. So we'll be talking about your recent study, Concurrent Validity of Novel Smartphone-Based Apps Monitoring Barbell Velocity in Powerlifting Exercises. So I read the study. I included the study in the research news show I do every month. So I'm excited to learn more. We talked a little bit before the camera started rolling, so I'm excited to hear first why you did the study and then how you went about it and what you found.
Well, the reason I did the study was I knew that there were multiple apps on the market for measuring barbell velocity. And I have to say, me personally, I was a critic. I didn't really believe that these apps would be really accurate. So we decided to take a look at how accurate these apps are able to measure the barbell velocity during lifting. But one thing that was really important to me is not just look at the absolute accuracy, like how big are the measurement errors, but how accurate are they compared to established technology. Because with every measurement system, there's always going to be some measurement error. So the question is not, is there a measurement error? The question is, how big is the measurement error? So what we did is we tested 3 apps: Metric VBT, Quick VBT, and MyLift. MyLift is currently in the app MyJump Lab. So depending on how you name it, it's a different name, but just for reference, I'm going to say MyLift. And we tested these three apps and compared them to a linear transducer, Rep 1. So what we did is we had the Baca system, so the 3D motion capture as the gold standard, and we let athletes lift, and then we looked, okay, how accurate are these apps? How accurate is the linear transducer, and how do they match up?
So I think we should also mention that all the measurements were performed at the same time. So each rep was measured via Viacon, linear transducer Rep 1, and 3 smartphone applications.
Yes, we had 20 study participants, and all of them performed an increasing load protocol where they all did single repetition sets, and they started with, I think it was around 50%, and they did 10 single repetition sets in the squat, bench press, and deadlift, increasing in intensity. So the barbell, it's not always just the same velocity, but the barbell also slows down. I will talk about this later, but it becomes very relevant because like sticking points and stuff where the barbell slows down only is after a certain intensity. And they did the squat, the bench press, and the deadlift for each 10 sets with 1 repetition each.
So what was the highest intensity roughly the athletes went? They didn't max out, so they didn't do 100%, but how heavy did they go?
The highest intensity was defined as 90% of the recent competition maximum.
Right.
So around 90%. Yes. And what we measured the mean concentric barbell velocity. We did not look at the peak velocity because for the powerlifting exercises, the mean velocity is the parameter of choice. For Olympic weightlifting might be different. For Olympic weightlifting, it's usually peak velocity. And what we found is that out of the 3 apps, Quick VBT performed exceptionally well. Metric VBT was, I would say, somewhere in the middle, where depending on the exercise, it was more accurate or less accurate, but not as accurate as the linear transducer, whereas Quick was. And MyLift was, out of the 3 apps, the worst, because first of all, it wasn't that accurate, but also so it had a lot of missed repetitions, especially in the bench press. And that's also what I would like to talk about next, because with every velocity measurement, there are two parts to the measurement, regardless of the technology. You have the first part of the measurement, which is just generating the raw positional data. So how far did the bar travel, in what time? And then from there, you can calculate the velocity. And you have to look at these two parts separately, because with the first part, that's a technology thing, like which technology are you using to generate the raw positional data. With a linear transducer, it's a cable pulled out of a box, so it's usually generally, it depends on the exact device, but generally it's quite good data. It's quite accurate because you have something physical pulling it out. With the apps, I cannot say this for certain because all these apps are closed, not open sourced, so I cannot look into them, but I can say with pretty high confidence that all three of those apps are using the plate, a standardized plate, 450 millimeters as a reference point. So and then they take the video and they know how big the plate is. So by knowing how big the plate is, they can calculate how far the bar traveled, and they have the time in the video. So then they can calculate the velocity. And once you have and that's how you get the raw positional data. And there's also differences in how well these apps did that. But for example, the second point, the rep detection and the velocity calculation. There are basically two thresholds which you need to consider. The first threshold is, in order for the app to detect the repetition, there need to be two thresholds met. The first one is a certain velocity threshold, because in theory, if the barbell would move at 0.01 meters per second for the whole repetition, it would be so slow that no repetition would be counted, depending on which threshold you choose. But if you set it really, really low, the repetition will be counted really fast, but you might include some other movement which is not the repetition itself in the calculation, skewing your measurements. But if you set the velocity threshold too high, you might have the problem that during sticking points or so, when you go under this velocity threshold for rep detection, the rep might be cut off and a second rep starts once you pass the sticking point, or in general, once you, for example, in a deadlift, if the lockout is pretty slow, you might cut off the repetition before it actually ends, thereby altering the result. So the first threshold, which you have to be very careful when considering, is the velocity threshold for rep detection. The second threshold you need for rep detection is a certain distance threshold, because if you have just, let's say, a 1 centimeter threshold for rep detection, you're gonna have the problem that every minor movement, just walking the bar out of the squat rack, is gonna detect like 20 repetitions. So you need threshold for also a distance threshold for rep detection. And this is, I cannot say this with certainty. I have looked at the data and it's just my guess, my educated guess. So, but that's, for example, where I think that the many missed repetitions from the bench press, from my lift come from, because we looked at it. And I personally think that my lift has this threshold for repetition detection at 30 centimeters. Everything below 30 centimeters, it doesn't detect as a repetition, and everything over it detects as a repetition. And we, as I said, we had experienced powerlifters with quite a big bench arch with trying to reduce the range of motion. So a lot of them had a bar path below 30 centimeters for the bench press. So my lift didn't detect the repetitions. But then that's like if you have a really high distance threshold, then there is no rep detection for like small repetitions. But on the other side, if you have a really low threshold for the distance, you run into problems with ghost repetitions. Because, for example, that's something we had with my lift. We had one study participant where with almost every bench press repetition with his lift off, or just lifting it out of the rack, he had, not with all of them, but with many of them, he had a ghost repetition from the lift off with metric. Because metric on the other hand, I don't have an estimate for where their threshold is, but their threshold seems to be quite lower. So then you run into those problems. So you have to look at the two things, the raw positional data like how you generate the raw positional data, and then what you do with this data at two separate tasks. And with the velocity measurement via these apps have some limitations in how you generate the data, but then what you do with this data, it doesn't there's no limitation, because that's where all the technologies, even the linear transducers, are working with the same thing. And I think just without even changing how they generate the positional data, these apps could optimize what they are measuring just by fine-tuning their thresholds.
Do you think that the quality of the camera with the application will influence how good the data is?
Yes and no. So the biggest limitation of the apps is the camera, as you said, because in theory, with a perfect high resolution, ultra high frames per second camera, these measurements would be almost perfect, because physically there's no disturbance. But again, in a real world scenario, there are a lot of co-founders which influence these measurements. And the biggest limitation of these apps are frames per second, which is, for mean velocity, it's not that big of a deal because you look at the whole repetition. But for peak velocity, it matters quite a lot. So that's also why some of these apps don't even really offer peak velocity as a measurement. And so for the smartphones, if you take the default setting, it's 30 frames per second, but you can turn it up all the way to 60 frames per second. And with 30 frames per second, the peak velocity measurement is accurate to somewhere around 0.7 to 0.8 meters per second. And with 60 frames per second, it's accurate to somewhere around 1.2, 1.3 meters per second for peak velocity. Again, this is not published data. This is just what we found through pre-study testing. And these are the limitations of the apps, because you would have to develop an own camera for higher frames per second, because this is all the iPhones offer. You cannot film with more than, actually I think with the ultra slow-mo, but that's also what the developers told me, like for these apps you're limited by like a maximum of 60 frames per second, and this only works to around 1.3 meters per second for peak velocity. After that it just becomes very inaccurate.
Thank you. That's very useful information.
Yeah, so with the study and everything which is talked about, with how these measurements work and what possible limitations are, and how like the processing from I perform a repetition to I get the velocity measurement, like the two steps. First you need the raw data, and then you have like the rep detection and stuff work. The question is what now to do with this information. And I would say, based on the study we did, I think that these apps, these applications can be great entry points, because especially for mean velocity, for powerlifting athletes, for weightlifting with peak velocity, maybe not that much, but especially, I mean, Quick perform as good, if not better, than the linear position transducer. So Quick for mean velocity is extremely accurate, so it just reduces the barrier of entry to velocity-based training, because if you download the app on your phone, as of right now it's still free to use. You just have to follow these instructions, place your phone in a stable stand, film your lift, and you get really accurate mean velocity measurements. If you want more advanced measurements like peak velocity and stuff like that, really accurate advanced measurements, it's probably worth investing in some technology like a linear position transducer or whatever. But just as an entry point, I think these apps are an excellent option, and especially Quick really delivers accurate measurements for mean velocity in all the powerlifting exercises, and there's basically zero barrier of entry because it's a free to use app.
That's awesome. All right, so the camera has to be on the tripod or somewhat fixed on the side side, so the plate is visible from the side angle through the whole repetition. Some apps like Quick will ask you to select the plate, which seems to be improving the accuracy and the calculations. And some of these apps will ask you to wait for the outcome. So because some coaches use VBT technology to cue the athletes. So as they go through the rep, they get the feedback of how fast they are moving. But it seems from what you're saying that with these apps, this is not the case. So
No, it's not. With Quick, it's not possible. With Metric and MyLift, it is possible.
okay, so they will.
So I would say just like it seems like the increased speed of the measurement comes with less accuracy of the measurement.
Right, good to know. Good to know. Yeah.
I don't think it's going to stay like this. I think because these apps are constantly improving. Because that's one thing you have to really give MyLift credit for, that MyLift was the first app to do this. And now, out of these 3 apps, I have to say that MyLift probably performed the worst, but it was the first app to do this. And you just see like the improvements from app to app. So I think because MyLift was the first one, then as the next big player, there was Metric, then there was Quick, and you just see that these apps are constantly improving, and that also the apps itself is improving. So for example, Metric, since we did the study, as far as I know, I think also Metric released a new update and so on. So these apps are not, that's also something I wrote in the study. These apps are not like frozen in time, like they are evolving, they're getting better and stuff. And I think like these limitations with the faster measurement comes with less accuracy. Maybe even in 1 year, this might not be the case anymore because these apps are just evolving. But the versions of the apps we looked at in this study, there it seemed to be the case that the 2 apps which offer the real-time feedback are less accurate than the one app that did not offer the real-time feedback. But in a few years, it might look completely different.
But look at us. We are talking of the technology that was 10 years ago was only available in labs, in scientific laboratories. And now we are debating which app is better and for what. If you want quick feedback, Metric and MyLift are the way to go. If you want accuracy, it has to be quick. But as you said, it's a snapshot. This is what we know now, and we will have to revisit. And the phones will get better, and people use tripods in the gym now to film lifts. It's not even weird anymore or, rare.
Yeah.
So,
Which is also one advantage of the apps, because many people, at least in the powerlifting community, already are filming their sets for like technical evaluation of the sets. Did I perform the exercise right? And they already have the footage which they need for looking at the velocity. So you don't even need to look, and like it's not even an extra step or an extra effort because they already have the footage they need. I could also talk a little bit more about the bench press if you want, because the bench press is different than the squat and the deadlift in the respect that for the bench press, the linear position transducer was less accurate than for the squat and the deadlift. And again, to say this with certainty, there would need to be a second study, but I took a deeper look at the data beyond what was published in the study, and it seems like that for the squat and the deadlift, the center of mass needs to stay, not now also for those two lifts, but always, the center of mass needs to stay above the surface of support. So your center of mass cannot move beyond your foot, because then you will fall over. With the bench press, since you're laying down, this is not the case. The bench press, you can have a lot more horizontal movement than in the squat and the deadlift, because you're laying down, your base of support is quite big, so you can have more horizontal barbell movement than compared to the deadlift and the squat. So you also have more horizontal barbell movement, and linear position transducer, since it's the cable attached to the barbell, is not, in my theory, is not able to perfectly differentiate differentiate between horizontal and vertical movement, whereas the apps and also the Vicon system is able to perfectly differentiate between the horizontal and vertical movement. So that's also one thing, because we had a slight overestimation bias with the linear position transducer in the study for the bench press. That's also something to keep in mind, that depending on which lift you perform, how much horizontal movement there is, different technologies also have advantages or disadvantages.
Your advice for coaches who are excited to use VBT, to play with it, what they should consider with when choosing setting up and then looking at the data and using it?
Well, my recommendation would be, if you haven't used VBT yet, to just try it out, see if it works for you, if you gain valuable insight for it. Because with these apps nowadays, the barrier of entry is so extremely low. As we discussed in length, Quick VBT is a really accurate app for measuring mean velocity. So just download it, try it out, make sure you follow the instructions, how the app is supposed to use, because if you follow these instructions or not will greatly affect the accuracy of these apps. And if you find that VBT is something you really want to use in your training and to look at it more accurately, then maybe down the road, maybe buy some velocity-based technology like a linear position transducer. But just for starting out, an app like Quick VBT is more than enough.
Sounds good. Awesome. 2 short questions to finish. The first one is, what is your favorite lift?
Well, my favorite lift, it always sounds stupid, it's the total. The powerlift lift, the only thing that competitive. Yeah, the total and the place thing.
That's awesome. Okay, I will let you pass with it. That's very funny. Okay, where people can find you if they want to follow your work and your journey?
Well, depending on what you're looking for, I think for just the research point of things, it's ResearchGate, Alexander Renner. And if you're also interested in my personal lifting, it's alex.renner.lifting on Instagram. Because there on the Instagram account, it's quite a mixture of the research stuff and the lifting stuff itself. So depending on what you're looking for, these are the two places.
Awesome. Thank you so much, Alex. It was a pleasure.
Thank you.